Welcome to another episode and video on my Raspberry Pi 1 running Raspbian Linux and using the RaspberryPi Plus on top of it, connected serially to Minicom console, also with Raspberry Pi camera right here. That is the serial cable. Raspberry Pi camera, which streams currently video straight to VLC application, and also network cable for VNC, virtual network computing, and band cable on the GPIO, general purpose input output. And the purpose is controlling electronics by means of I2C. And for that there's this breadboard with electronics and some fischertechnik. And okay, that's better. And lately there have been some problems, and last time there were really severe problems with it to get things working. Eventually I managed, and that was particularly here with the wiring. So I haven't tested things yet, so I don't know if that will work, but to another change, a little change is that I've put the fischertechnik LEDs on well, elevation, because from this point of view you can see them, but from the camera, which is already a little bit tilted because of the view. Otherwise you would see a lot of other things that have nothing to do with the project, and I can't cover everything. So this will work, hopefully. The switch is alright, that does work. Last time I found out how things worked, and it does go okay now, except for one thing, that some things do not work quite as well as I had hoped. With the demo application things do work very nicely. With the wiringpi, which adds all the LEDs up, and then they should go the other way, not so much. So I adapted the algorithm last time, but let's see how things work out now. I'm very curious. And there's another change that I will show you on the screencast. So let's see what. Alright, so now you can see here the LEDs on the elevation. Another thing is that I have this VLC by streaming video, and here is a problem. I very recently upgraded my operating system version, and what you used to see is this view. Well, that is to say, you used to see it without me taking care of it. High definition view with the same command as I use now. So where's the high definition? And you see it's been running for a while. That's because I have tried to get it running normally, and that is not happening right now. So I'll have to do with it, I think, although I don't like it. I got some errors in between. I'll show you some value errors, but I'm not quite sure why it is. It is connecting because I get an image anyway. So this is what it is about. And this is also the reason that I have elevated the LEDs, so I can show you them working. That said, let's see if they work. Oscilloscope set to I2C, and there we go. Well, they do work. I get nice I2C signals. Here I see the LEDs working. What am I seeing here? Nothing, because the LEDs are, well, let's say hidden behind these wires. You will only see these ones. Alright. Then time to press a button. And okay, here comes something inconvenient. I have to do it with my other hand because otherwise everything is shielded. So, button pressed. Yes, because I'm doing so. Oh, I see a problem. Right here, wiring is out. So I have to put in the wire right. Oops. It has to be a nice wire, nicely twisted. Into the band cable for the GPIO. And currently it does not really cooperate. Now it does. Alright. Stubborn wire, but let's see. Yeah, that works. So can we see it right here? Yep, nicely done. So that's alright. And then for the algorithm, what does the algorithm do anyway? Yeah, I had to put everything in here because I've been I was struggling last time quite a bit because the switch was not recognized in the algorithm that I could see. So now I have a GPIO read here, and here this is the GPIO read for the switch, and this is the GPIO write for the LED. This LED. Here you can see the LED going here as well, by the way, which is because it has added everything what should be added, and then it is just adding each LED. So that works nicely now. The other thing is, it doesn't do yet what I want it to do. because right now it starts here and ends up here. As what I want to do it is, if possible of course, press a button and have it the other way. Problem is of course that I have 8 LEDs, 7 here and this number 8, and it takes a while before it has completed. So when does it take the LED? When does it take the switch and turn it around? Can I interrupt it? I might. But right now it doesn't do a thing, it just signals the switch being pressed or not being pressed, and just goes, just does what it has been doing for all this time. And this is 0 to 2024. Yeah. And that takes a while. Right now it's at Y is 217, and with 2 seconds per count, one, two, yeah, say 2 seconds per count, so 1024 times 2 seconds, that's quite a long time. I could reduce it of course, speed it up, and already did speed it up because I changed this delay in the past. This delay is how fast it ends, and it was 50 and I increased it to 500 to see whatever it did anyway. So after this, what to do? What is nice, what is not nice? I think first thing to do is decrease this one, and of course I can just interrupt this program and then see what I have to do. Alright, so let's speed things up a bit. Dividing by 2 gives 512. Dividing by 4 gives 265, 256. Let's do that. Okay. I don't know what effect it will really have, like LEDs that not going to burn. I don't know yet, but let's just make it 256. Let's do that. Yeah. So right, compile nicely and go. Okay, twice a second, then I should add up a bit, speed up a bit. Okay, I'm going to speed up things. Let's say that is line 66, and I make this 250. Alright, compile, done, go. Alright, this is working quite fast, but how about this one versus this one? What I can do is look how this is working by just disabling this one. Let me do that for a moment. Or am I? This is the whole loop. Within this loop, this will count up. This will just be busy for that time. Oh wait, I should be more specific here, because when I want to know in which loop I am. So this is bit up. Yeah. And then this is of course bit down. No, not like this. And I could have said in Dutch op and neer, but up and down is the same, whatever. Okay, now let's see whatever happens. I'm quite curious now. No, that's not a point. I have to compile first. Alright, quite fast. Go. Down. It is going down now. Down is 10. Okay, I'm surprised. It doesn't count down. Why doesn't it count down? Because that goes on forever. This is strange. I didn't expect this to happen. Okay, wait. 16. Wait a second. 26. 11. Okay, I have to be careful now. Right here. It is okay, fine. Then binnen for 3 is this one. Right here. Bit up is 0. It says bit up is 0, so it's in here. It goes like up is 9, delay, bit down is 10. It enters this one. Then what happens? Zero, bit up is 0. Very good. Bit down is 10, 9, 8, 7, 6. Ah, right. When things go slow, you see whatever happens really. So it does do those two things after another. Down and up. Right. That means when it goes that fast, wait a second. If this is true, then why do I see it written like this? Why don't I see it go down? Because here exactly the same happens. It does exactly the same. So I should actually go the other way. Let's replace this. And replace this by this one. And see whatever happens then, because so far the algorithms have been exactly the same, so it doesn't matter if you count down or up, it does the same. And I don't want that. Alright. Another attempt. No compilation error, so that's one thing. But now, whatever happens, okay, let's stop it for a bit, because it's still counting. Yeah, it's still counting up. So what's going on? Alright, so let's examine. Where am I exactly? 22. Okay, I have to go back 22 times. Oh, 34. No. 18. 12. 0. Okay, here. So whatever happens. Bit up, bit down. Bit up is up to 9, bit down is 9 down to 1, but what is it writing anyway? It is writing Y, logical AND, and one shifted bit. So it may not actually do anything correctly. I want to know what it writes anyway. I could do that, of course. Where am I? Right here. So I am adding and now, yeah, confusing for those who don't speak in Dutch, but the number is oh wait, I'm not doing that correctly, because what is it writing? That is the whole problem. What is it writing anyway? To know that best, I should know what digital write means. Where does it come from? Well, of course, wiringpi. That's a good one. I suppose it is an address plus a value. And I am assuming it is an integer. So let me put this in it. And then I will know something. Oh wait, let me change this back to plus, because this looks like the real value that it writes to one address. Now let's see whatever happens. Quite curious. And I have to keep in mind that time is going on, and it's not long before I have to close this video, to end this video. So let's yeah, bit down and then the number is written. Okay, that's good. Okay, and what is going on? And this is quite soon. No. Een, nul, 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 nul. Oh wait, I forget something, which is quite helpful. /n, new line, to distinguish between all lines. But I already see that it starts with 0 and then zeros. Okay, let's see anyway. Yep. Compile. Took a little bit longer. Go. It writes zeros. And then a 2, 4. Okay, let's quit. So 1 0 0 0 0. And here it writes 0, all zeros. Going back, all numbers are 0. And this is, by the way, up. It is going up. So that is this original part of the algorithm. And here it writes 0 0 0 4 2. Here 1 2 1, 2, 4, all zeros, and this is a up again. And here it says all zeros ending with 4 and 2, and this is down. Assuming this is a digital counter, then you have from left to right, no, from right to left, 1 is 1, 0, 1, so still from right, writing from right to left, 0, 1 is 2, 0, 0, 1 is 4. And if you have 2, so if you have 1, 1, it means digital 3. And 1, 0, 0 is 4. So that would mean that if it is binary, the third LED would burn and the rest would be off. Is that indeed the case? Close examination, but it goes very fast. It actually counts binary. But the whole point is, if this goes very fast, as you can see this is going very fast, then how come the counting is going the same? So that is very mysterious, and I have to go deeper into that. Yeah. And time is up. Alright, so some new stuff done. Well, new, analyzing the algorithm and finding out that some things don't match with what I see. Anyway, I have to take another closer look. For now, thank you for watching. If you like this video, please subscribe to my channel, give the video a thumbs up, and leave a comment or suggestion. You can also follow me on Twitter. Please retweet, like, and leave a comment. You can also follow me on Instagram. Please like and leave a comment. You can show your appreciation of my videos by making a small donation via PayPal or Wired. You can also become a patron and have your name mentioned. More information at the start of this video or under this video in the description box. And see my website for more information. Thanks for watching, and to be continued.